There it goes. Okay.
Okay, I'm lecturing from the notes. This is not in the book today, and this is really for the AP test. So it's how to find an inverse, the numerical value of an inverse, even if you don't know how to take the inverse. Okay, so sometimes it's really hard to swap the x and y and figure out what the inverse is, but you can get the numerical value of it with a formula we're going to go over today. So just going over the bullets at the top of the notes, if f is continuous, then the inverse is continuous. If f is differentiable, then the inverse is always going to be differentiable. If f is increasing, then the inverse will always be increasing. And if f is decreasing, then the inverse will always be decreasing. So in the next bullet, there's a formula where you can find the numerical value of the inverse. And that formula is, so there's a little space for you to write that. So the derivative of the inverse is equal to 1 over f prime of the value of the inverse at whatever point you're looking for. So this is called the numeric value of the inverse. And that'll always be given in the problem. So f prime just means you take the original function and take the derivative of it, and then you put whatever value you're trying to figure out of the inverse in that, and then it's 1 over that, and that gives you the value of the inverse at a certain point. All right, so the next bullet says, before I work the 2 example problems, is you can see that f of x and the inverse have a reciprocal relationship. Okay, so you can see that it's 1 over there. So the slope of f of x at point x is equal to the reciprocal of the slope of the inverse at a point. So if the slope at a particular point for f of x is 2, then the slope for the inverse will be 1/2. Okay, that's all that means. All right, let's work the 2 examples, and this is one of the shorter lectures of the year. So it says, given that f of x is equal to 2x plus cosine x, and the value of the inverse at pi is equal to pi over 2, find the value of the derivative of the inverse at x equals pi. Okay, so the first thing you do, you really just got to memorize this procedure. Take the derivative of the original function f of x. That's going to be 2 minus sine x. So the value of the derivative, or another way to say this, is the slope of the inverse at x equals pi. That's what we're trying to find, slope of the inverse at x equals pi. So the way you would write that is inverse at pi is going to be 1 over 2 minus sine of pi over 2. Okay, that's where that comes from. Okay, so the value of the inverse, the y value at pi is pi over 2. So that's what you plug in. All right, so that's just going to be 1 over 2 minus, and then do you remember what the sine of pi over 2 is? It's the one that's straight up.
Is it 0? No, it's 1.
It's 1. All right. So that's 1 over 2 minus 1, which is 1. So what that means, what does that mean? All right, that's a bunch of fancy. This is the slope of the inverse function at x x equals pi. So even though we don't know the actual function, what the function is of the inverse, we don't know that, we can figure out the slope with this formula. All right, so I'm gonna go ahead and, for better video, instead of trying to squish all the next one down here, I'll erase this. All right, and the next one is we have f of x is equal to x cubed plus 2x minus 1, and the inverse value at 2 is equal to 1. We want to know, find the value of the derivative. So we want to find the value of the derivative, so we'll call that f prime of the inverse at x equals 2. Question mark. All right, so we're going to take the derivative. That's 3x squared plus 2. All right, so the value of the derivative of the inverse at x equals 2 is going to be 1 over, and what am I going to plug in here for x?
3x squared plus 2.
No, what am I going to plug in?
Oh, for x. 1.
1, right? Don't accidentally plug in 2. That's what you're trying to find.
Mm-hmm.
But you have to take that value, so you... All right, so that's going to be 1/5. All right, and we can actually check this if we want. You don't have to. I wouldn't ask you to on the test or anything. But since there's a reciprocal relationship, what should the slope of the derivative be at 1? What's the reciprocal
5.
of this? Should be
Negative,
5.
yeah.
So we could check and just figure out, okay, what is f prime of 1? That's going to be 3 times 1 squared plus 2, which is 5. So that's a way you can check it if you want to. Okay, so the homework is the worksheet. There's 6 questions. The 2 that are multiple choice refer to the notes above the example problem. So you'll just kind of have to look at those to answer the questions. And then the other 4, 1, 3, 4, and 6 are all these kind of example problems. So you can do it. So you can go ahead and stop the video.